Welcome to Tech Prep video tutorials. In week 5 of physics, we will do 2 more questions from kinematics. Question number 1. A stone is dropped from the top of a tower. When it has fallen by 5 meters from the top, another stone is dropped from a point 25 meters below the top. If both stones reach the ground at the same moment, then we have to find the height of the tower from the ground. Here we can use G is equal to 10 meters per second square. Now we have to find the solution. Let A and B be 2 stones. For stone A, the initial velocity is equal to 0. So after falling 5 meters, the speed of stone A is VA is equal to square root of 2 G into 5, which is equal to 10 meters per second. If h is the height of the tower, then stone A has to descend h minus 5 meter and stone B has to descend h minus 25 meter. Since both stones reach the ground at the same moment, h minus 5 is equal to 10t plus half gt square and h minus 25 is equal to half gt square. Now subtracting equation 1 and 2, we get 20 is equal to 10t, which implies t is equal to 2 seconds. Now putting the value of t in equation 2, we get h minus 25 is equal to half into 10 into 2 square, which is equal to 20. Therefore, h is equal to 45 meters. So, the answer is option D. Now, question number 2. A train starts from rest from station A and stops at station B. The acceleration of the train varies as A is equal to k1 minus k2x, where k1 and k2 are constants and x is the distance from station A. Now we have to find the distance between the 2 stations and the maximum velocity. Now acceleration of the train A is equal to v dv by dx, which is equal to k1 minus k2x, which implies that integration v is equal to 0 to v dv is equal to integration x is equal to 0 to x k1 minus k2x within brackets into dx. This implies that v square by 2 is equal to k1x minus k2 x square by 2, which implies v square is equal to 2 k1x minus k2x square. Since at both the stations the train is at rest, putting v is equal to 0 in the above equation, we get x is equal to 2 k1 by k2, which is the distance between the 2 stations. The train accelerates, still the acceleration does not become 0. Putting A is equal to k1 minus k2x is equal to 0, which implies x is equal to k1 by k2. So the train accelerates up to x is equal to k1 by k2 and then retards to rest. Putting x is equal to k1 by k2 in equation 1, we get v maximum square is equal to 2 k1 into within brackets k1 by k2 minus k2 within brackets k1 by k2 whole square, which is equal to k1 square by k2. This implies maximum velocity is equal to k1 by square root of k2, which is the option D. So here the answer is option D.